Imagine a spacecraft hurtling toward our sun, facing temperatures that would instantly melt most materials, and getting closer to our star than anything humanity has ever sent before. That's exactly what the Parker Solar Probe is doing. Launched in 2018, this probe is pushing the boundaries of our knowledge, diving into the outer atmosphere of the Sun, called the corona, where it's gathering data to answer some of the most profound mysteries of our solar system. Join us as we explore what this incredible mission has revealed so far, the engineering marvel that makes it possible, and the questions we're hoping to answer by sending a probe closer to the Sun than ever before. Are you ready to venture into one of the most extreme environments in our solar system? Our Sun is the central engine of our solar system. It's the reason Earth exists as a habitable world. But for all that we know about it, the Sun remains deeply mysterious. Most stars we see in the night sky are far too distant to study in detail, but our Sun, at just 93 million miles away, offers a unique opportunity to observe a star up close. Let's take a moment to consider why we study the Sun at all. For ancient civilizations, the Sun was more than a star. It was a god, a source of life and energy. They celebrated its warmth, worshipped its power, and built monuments like Stonehenge to track its journey through the sky. Over millennia, we've come to understand that the Sun is a giant ball of hot plasma, powered by nuclear fusion. But while we've unlocked some secrets, there are still some puzzles we're only now starting to solve. One of the biggest mysteries is what scientists call the coronal heating problem. The Sun's corona, the outermost layer of its atmosphere, has a temperature of about 1 to 2 million degrees Fahrenheit. However, the layer just beneath it, the photosphere, is much cooler, around 11,000 degrees Fahrenheit. This creates a puzzling situation. Why does the temperature increase so drastically as we move further from the Sun's surface? You'd expect the opposite. This is where the Parker Solar Probe comes in, helping us to understand this temperature inversion and how energy flows within the Sun. Now, sending a spacecraft into the Sun's atmosphere is no small feat. For years, scientists dreamed of studying the Sun up close, but the temperatures and radiation made it seem impossible. That all changed with advancements in materials science and engineering, leading to the development of the Parker Solar Probe. Named after Eugene Parker, a pioneer in solar science, this probe is unlike anything that's come before. Eugene Parker was the first to propose the idea of the solar wind, a stream of charged particles flowing outward from the Sun. Back in the 1950s, this was a radical idea, but over time it was confirmed, and today it's a crucial part of our understanding of space weather. The Parker Solar Probe is designed to survive temperatures of over 2,500 degrees Fahrenheit. Its heat shield, made of a special carbon composite material, acts as a barrier between the Sun's intense heat and the probe's sensitive instruments. This shield, called the thermal protection system, is 4.5 inches thick and coated with a special white material that reflects sunlight. Without this shield, the probe wouldn't survive even a fraction of a second in the Sun's corona. One of the most fascinating aspects of the probe is its unique orbit. Instead of a direct plunge, the Parker Solar Probe will circle the Sun, gradually getting closer with each orbit. Over the course of its mission, it will make 24 close approaches, or perihelions, reaching a minimum distance of just 3.83 million miles from the Sun's surface by the end of its mission. To put that in perspective, that's about 7 times closer than any previous spacecraft has come. So, what exactly is the Parker Solar Probe hoping to achieve? There are 3 main objectives. Why does the Sun's atmosphere get hotter the farther away it is from the surface? By flying through the corona, the probe will measure the plasma directly, helping scientists understand the mechanisms that heat it. The solar wind is a stream of charged particles constantly flowing from the Sun. While we know it exists, we don't fully understand how it's generated and why it behaves the way it does. The Parker Solar Probe will help answer these questions by taking measurements directly within the solar wind. These high-energy particles are a major component of solar radiation and pose risks to astronauts and satellites. By studying them up close, we can learn more about how they're accelerated and how they might affect future human missions to Mars and beyond. Each time the probe gets close to the Sun, it collects data on these objectives, giving scientists a wealth of information to work with. Launched aboard a Delta IV Heavy rocket, the Parker Solar Probe began its journey in August 2018. This launch marked the beginning of a 7-year mission, with the probe's first close approach to the Sun occurring just a few months later. But how does a spacecraft actually get close to the Sun? Achieving this mission required the Parker Solar Probe to use a series of gravity assists from Venus. These gravity assists, or slingshots, allow the probe to adjust its speed and trajectory, bringing it closer to the Sun with each orbit. This isn't just a shortcut, it's a vital part of the mission design. By swinging past Venus, the probe sheds energy, allowing it to fall closer to the Sun. Each orbit brings the probe into regions of space no other mission has explored before. Each flyby has been a thrilling moment for scientists, and each time, the Parker Solar Probe pushes the envelope of what we know about our star. Since its launch, the Parker Solar Probe has delivered some incredible discoveries. One of the most exciting findings has been the observation of switchbacks in the solar wind. These are sudden reversals in the magnetic field direction, causing the solar wind to switch back on itself. This discovery was a complete surprise, and has led scientists to rethink their models of the Sun's magnetic field. The Parker Solar Probe has also measured incredibly high temperatures in the corona, validating some theories and challenging others. For example, the probe found that particles in the corona are much hotter than expected, supporting the idea that magnetic reconnection, where magnetic field lines break and reconnect, could be responsible for the extreme temperatures. In April 2021, the Parker Solar Probe made history by flying directly through the corona, marking the first time any spacecraft had entered the Sun's outer atmosphere. During this flyby, the probe was able to directly sample particles from the corona and send back data on their composition and energy. This historic moment is akin to touching the Sun itself, a goal that scientists once thought impossible. Each close approach reveals more about the Sun's behavior. The Parker Solar Probe's data is helping us understand space weather and how solar activity affects life on Earth. Why does it matter if we understand the Sun? The answer lies in the concept of space weather. The Sun is constantly sending out streams of particles that affect our planet. While most of these particles are deflected by Earth's magnetic field, major solar storms can have serious impacts. One of the most famous events in recorded history was the Carrington event of 1859. During this solar storm, the northern lights were seen as far south as the Caribbean, and telegraph systems across Europe and North America failed. If a similar event were to happen today, it could cause widespread blackouts, disrupt communications, and damage satellites. In 1989, a solar storm caused a 9-hour blackout in Quebec, affecting over 6 million people. These storms aren't just hypothetical scenarios, they're real events with the potential to impact our daily lives. By studying the Sun's corona and understanding the mechanisms behind solar flares and coronal mass ejections, the Parker Solar Probe is helping us prepare for future space weather events. The Parker Solar Probe is part of a long tradition of solar exploration. Missions like SOHO, the Solar Dynamics Observatory, SDO, and now the Parker Solar Probe have given us a better understanding of our Sun. Each mission builds on the last, adding to our knowledge and preparing us for future missions. In a way, the Parker Solar Probe is Eugene Parker's legacy. His groundbreaking work on the solar wind changed our understanding of the Sun, and now a spacecraft bearing his name is rewriting the rules once again. Before his death in 2022, Parker expressed his excitement for the mission and what it would mean for humanity's knowledge of our Sun. What's next for solar exploration? The Parker Solar Probe will continue to orbit the Sun until 2025, after which its instruments may no longer function in the extreme environment. But even as it completes its mission, scientists are already planning the next steps. One possibility is sending a mission to the Sun's poles, which could offer a unique perspective on the solar magnetic field. Another is developing new types of heat shields that would allow probes to get even closer. Each new mission brings us closer to understanding the Sun, a star that holds the key to understanding all stars in our galaxy. So, as the Parker Solar Probe continues its journey, it's pushing the boundaries of what we thought possible. Every close approach brings us closer to answering fundamental questions about the Sun and space weather. It's an incredible time for solar science, and this mission is a testament to humanity's quest for knowledge. What do you think? Do you believe the answers we find in the Sun's corona will change our understanding of the universe? Let us know in the comments below. Don't forget to like, share, and subscribe to Curious Explorers for more explorations into the wonders of our universe.